Okay, we're still having the same issue here. This is doing something only if I press the button. It's a defined state. If I release the button, it's not defined, something is happening. Yeah. If I pull this out, set it to exactly minus, it's off, like we expect. Yeah. So that's the issue here. That's the thing. We could use a different type of switch. Yeah? We could use a switch which is not switching between nothing, like now, or 5 volt or nothing. We could use a switch which is switching between 5 volt and 0 volt. We don't have such a switch. Yeah? But I show you now something. If I plug in here another cable, I pull this out. Yeah, this is now in the air. Yeah? This is doing something, and if I just touch those two things, my body is enough that if I release, yeah, it's already doing something. But my body is enough that I define the value of voltage on this line. Yeah? So I could plug it in here. I use another cable. Yeah? And if I now touch both cables, I'm pulling this line here to 0 volts. And if I press the button, it's working. Yeah? Now I have 5 volt. If I release it, 0. If I press, 5. Yeah? I'm using my body to pull down this line to 0 volt if the button is not pressed. Yeah? And the 5 volt, I don't even feel anything. My body withstands the electricity good enough that this 5 volt or 5 volt are not that dangerous. Okay, so this is how it should work actually. However, if I let it loose, it's still the same thing. So instead of my body, yeah, you could also use these things here. Resistor. Yeah, but we will not use this, we will use this 100k resistor, high value, because my body is also not that low on resistance. So I will use a resistor to plug between the cable and ground, and now this resistor is pulling down this line to 0 volt. If I press the button, the resistor is big enough that the 5 volts are still there. Yeah. If I release the button, this is how it should work. Yeah. Now what is happening is that this resistor is defining the potential, the voltage level of this line in case I don't press. If I press, the resistor is big enough. I mean 100,000 ohms, 1k, yeah. 100k, 100,000 ohms is big enough that it's not disturbing. Yeah. Release it, this is. And because this resistor is pulling the voltage down to 0 volt, this thing here is called a pull-down resistor. Pull-down resistor. We could do it another way. Yeah. I remove this here now. Pick. I will take a blue one for better indication, even if electricity does not see color. However, I will pull this now, put this in here now at ground level, and I change the resistor not to 5 volt, not to 0 volts, but I change it to 5 volt. So now this resistor is pulling this line to 5 volt, and if I press the button, I bring it, nothing happens. There is somewhere. Okay. If I push the button, I bring it down to 0 volt. You have seen this may happen, then you wiggle around a little bit. Yeah, that's the disadvantage of these breadboards. Yeah. Again. Press the button, 0 volt, release the button. This thing is pulling it to 5 volt. Because it's pulling up to 5 volt, this thing is called Pullup-Resistor. Yeah? And of course, now if we don't press the button, we have here 5 volts, so we are reading true. And because we're reading true, we're giving out a signal to turn on the LED. So it's now working exactly vice versa like before. Why I'm telling you this? Why am I telling you this? Because, I mean, the program is still the same. The program is still as before. However, our Arduino, our little Arduino here, does have such pull resistors already built in. Yeah. However, it's just a pull-up resistor, not a pull-down resistor. This is why I showed you the pull-up resistor also as physical element. Yeah. If I change here this definition from input to input pull-up, yeah, and now download it, yeah, then this internal pull-up resistor is in place. It now works exactly as before. Yeah. Reliable. And now I can even remove this resistor and it's still working. The only issue right now is that it's working the other way around. So you have to press the button that it's out. I have to release the button that it's on. But with this simple line here, input pull up, yeah, we activated this pull up resistor and suddenly the input is working properly. Yeah. Your task is that you now change the program in a way that this is working also. Maybe some of you noticed I made here a little bit change in the program. Before it was written like this, button state equals 1. That's not really necessary, because in C++, you know, every value not equal to 0 is taken as true, and every value which is 0 is taken as false. So it's enough if I just ask if button state, because if it's 1, so not 0, it's true, and if it's 0, so nothing is reading, then it's false. Yeah, so it's shorter. Would be okay. Okay, so that should be sufficient. Like I said, your task now is that it works like before. Press the button, light, no button, no light. Use the pull-up resistor of the Arduino that it's working reliable. This is how it should work. Press the button, light, release the button, no light, internal pull-up resistor in place, no external resistor, working reliable. Good luck with this. Thanks for your attention.